Welcome. My name is Whitney Lee. I'm a CNCF ambassador, and I'm here with Austin. Austin, will you introduce yourself, please?
I would be happy to. I'm Austin Parker, Director of Open Source at Honeycomb.io and a maintainer for the OpenTelemetry project. I serve on the governance committee, which is our steering committee. I've been involved with the project since before it was OpenTelemetry. I used to be a maintainer on OpenTracing, which is another CNCF project. I've written exhaustively about it. I actually have a new book that's out called Learning OpenTelemetry on O'Reilly, if you're interested. But yeah, I've been working with this stuff for nearly a decade now, and wow, that's a long time.
Well, welcome. I'm so glad you're here. So Austin and I just had a 2-hour-long conversation talking about OpenTelemetry. I'm a relatively new learner, or I know just enough to be dangerous, I think. And I've been asking Austin to explain it all to me. And as I've understood things, I've been writing them on the board, and we will link to that 2-hour conversation in the description here. But meanwhile, maybe you don't want to watch us talk for 2 hours and you just want to see a little recap. In that case, you're in the right place, because we're going to go over everything we talked about. We started by you giving me a history lesson, how OpenTelemetry started in 2017.
2017-ish, the pandemic did a real number on my ability to conceptualize linear time, so dates may be a little off. But, if you think back years ago, open tracing was started with this idea that we needed to popularize distributed tracing. And to do that, we needed a kind of a standard way to create distributed traces between different services in a system. And we worked with a variety of people in the community, including the maintainers of projects like Jaeger and Zipkin. And we created this project called Open Tracing that provided a standard API to build distributed traces. Meanwhile, Google had been working on something very similar called Open Census. We were both in the same ballpark, but maybe on different sides of the field, as it were.
Yeah.
And both projects were sort of competing in people's minds and sort of competing with each other. And we stopped one day and said, well, what is it that we actually really care about? And I think that both projects really deeply cared about this idea that telemetry data needed to be a built-in part of software. And so in 2019, we came together to say, hey, let's merge this. And in 2020, OpenTelemetry was born.
So then let's dig into what is OpenTelemetry exactly. Let's get a definition.
So there's the definition on the website, right? And it's to make high quality ubiquitous telemetry a built-in part of cloud native software. But I think the definition that you came up with, actually, I really like better, which is it's a model for how to translate system events into useful data for observability.
I have questions from here, but one thing I think is worth saying is how vast and unknowable the number of events there are in a system. There are application level events. There are events about how applications are connecting with one another. There are infrastructure and system level events. All of your third-party tools are emitting events. So it's wildly complex from that standpoint. And then you mentioned another level of complexity, which you called semantic observability. Will you speak to that?
Semantic observability is really this idea that how we translate those system events into signals, into things, actually matters a lot for the consumers of those events. We can think about it at a role level, right? If I'm a security engineer, then I care about different things, maybe versus being a developer or being a DevOps person or an SRE. Now, it's the same events that I'm looking at the end of the day. I'm looking at how many people are accessing my website or how much memory is this using. But how I interpret that data matters a lot. And if I'm writing tools that kind of help me understand my system, then having this really strong schema and these really strong semantics for how that data is represented can be really beneficial in building better tools and also in making it easier for me as a consumer of telemetry data to understand what that data means.
So back to our definition, OpenTelemetry is a model for how to translate system events. So system of events being all the different places in your system, all the different people who might see the events, all the different pillars, the log signals, logs, metrics, traces. So that's wildly complex and to useful data for observability. So here's another question just from this definition. What does it mean for telemetry data to be useful? What makes data useful?
That's an excellent question. What we believe as a project, and what I kind of personally believe too, is that from observability data to be really useful to any number of end users, it needs to be ubiquitous. It needs to be kind of standard and available everywhere. So it needs to be available from your app, from your cloud, from your container runtime, IaaS provider, whatever. Mm-hmm. And it needs to be pretty standard, right? The data that I get from one cloud to another should at least have stuff in common. A host is a host is a host. A container is a container is a container. Now, obviously, there can be distinctions between different features and functionality that maybe I get from using one container runtime over another. But at the end of the day, a container should still be a container regardless of how I'm running it or where I'm running it. So that's one part about it, that sort of standardization part. The second is that I need that data to be correlated with other things that happened. And I want that correlation on kind of a lot of different ways. I want to be able to ask, when this transaction or this database query was happening, what else was happening on that same node, on that same host, in that same database cluster? Or maybe for a single end-to-end transaction, like someone adding something to their cart in an e-commerce store, what are all the different events that happened across this entire system that relate to that one single transaction? And OpenTelemetry gives you the way to kind of solve both of those problems.
So we talked about the system events OpenTelemetry is looking for as part of the definition. We talked about what it means for the data to be useful. It needs to be standardized. It needs to be correlated. Mm-hmm. It needs to be ubiquitous and that's pulled from all different points in the system. The other point is that it's a model. What does it mean that it's a model? What components make up OpenTelemetry?
There's a lot of different components in OpenTelemetry. The lowest level thing is this sort of conceptual model we just talked about. But then on top of that, it's the standard for the data itself. It's how do you represent that data and communicate it between various actors in a system. Then on top of that, you have an API, you have a specification for how do you define that data and how do you write that data and what are the functionality of it so that people can build interoperable systems of telemetry. And then it's software based on that specification that help you actually do this. Things like a collector to collect that data, an API to help you write to translate those events into signals, and SDKs that help you actually generate the data and do all that sort of contextual association stuff we just talked about.
So we're going to dig into those three things just a little bit more because that's definitely going into this conversation a big part of where my mental model was lacking. OTel API, of these three different software pieces of it, the OTel API is the lowest level one. And that's what developers are actually using to translate code level events into a signal. And you also taught me that the OpenTelemetry API has an implementation for each language. Then we have the OTel SDK that listens to signals from the OTel API and does cool things. What are some examples of cool things that it does with those signals?
The coolest thing, I think, is that that's where sort of that context layer operates, right? When you emit a span or a log message or anything into the SDK, it says, what is the current context of whatever's happening right now in this thread, in this request, whatever. And it adds that information to that event, to that data point, to that span. Then it passes it down the line. And it does this without you having to actually tell it to, right? Like it's just aware of the context that you have set up. It'll go in and it'll just kind of add that stuff in there for you and you don't have to think about it.
That automatic element feels really magical to me. That's awesome. And then speaking of it automatically adding context, you talked about it adding also metadata context. You've talked about OTel semantic conventions. Will you talk about what that is some more, please?
When we were talking a second ago about this idea of like ubiquitous standardization, right? And the idea that the data should kind of look and feel the same regardless of where it's from. The semantic conventions are how we do that as a project. A good example is an HTTP server. You can have a bunch of different implementations of an HTTP server in different languages, but all of those things are going to have a few things in common. When you have a response, it's going to have a status code. When you have a request, it's going to have some sort of URL. The semantic conventions define how that data, all of those different things, so that whenever you see, some piece of telemetry that OTel generated, it doesn't matter where it got generated from. If it's an HTTP span or metric, it's going to have these things in common, regardless if it was generated by, Spring Framework in Java or net/HTTP in Go, right? And that consistency is provided by the SDK kind of adding in that metadata through mechanisms like resource detectors or through instrumentation libraries that can be written and plugged in.
So now we have the data collected with the API. We have it highly correlated with the SDK. And now we can do stuff with the data. How do we do stuff?
We need to take that data and put it somewhere, right? And you could, if you wanted to, you could just say, like, push all this data from my Java app to some database. Totally valid. But a lot of times, when you're dealing with telemetry data, there's a ton of it, and it's not all equally useful. Sometimes there's stuff in there that you don't want to be in there, like PII. You might need to redact information. You might want to drop information. Maybe you have a health check that is just every 5 seconds is just creating data, and you don't really care about having telemetry for that health check. You just want to know, is it up, is it down? The collector is sort of a Swiss Army knife tool that you can add in to do that kind of interesting transformation. Treats your data as, you set up these pipelines in it, and you can do things like obfuscate or remove PII. You can deduplicate data, just filter things out. You can sample, so you can say keep a percentage of telemetry data and based on various heuristics. There's a ton of stuff you can do with it. And it can also be used as sort of a way to take telemetry that doesn't start in OTel format. So maybe you have system data, right? You have like infrastructure metrics or logs, and you want to get those into your OTel data pipeline and get all that great correlation stuff. You can use the collector for that as well. You can point it at system logs or event logs. You can point it at host metrics, and it'll take those, do that same sort of resource hydration where it adds the appropriate semantic conventional data, transforms stuff into the semantic conventions for you, and then sends it on down the pipe with the rest of your data.
That all sounds awesome, but maybe if I'm already only using Prometheus just to do metrics and none of the correlation or deeper data stuff, as part of Prometheus, I can drop stuff. I can obfuscate PII. Like, what benefit am I getting from putting in all the work to get all these correlations done?
I think that what I've seen when I talk to people that are kind of adopting OpenTelemetry is that there are a lot of challenges in kind of observability that are hard to do with just Prometheus metrics, right? Or just metrics and logs. They want to move to a more holistic observability strategy that doesn't look at these pieces of telemetry as isolated, pillars. They want to look at them as this correlated stream of data or braid of data that we've talked about here. Yeah. And one of the cool things about OpenTelemetry is we work really closely with the Prometheus maintainers, and we're actually, kind of aligning these two projects more and more over time. So like in the future, Prometheus will actually be able to just you start using the OTel SDKs natively. It'll start accepting OTel data natively. And the OpenMetrics format that Prometheus uses is actually just a subset of what the OpenTelemetry metrics specification lets you do. So if you're using Prometheus today, then you can kind of plug in OTel and just start getting more out of that existing Prometheus instrumentation, or those existing Prometheus metrics than you could by keeping them separate.
Like when I'm investigating a bug, being able to do it with this correlated data will help me with that investigation. Can you paint me a picture of what it feels like to have correlated data?
you don't run into dead ends as much. So one thing that I think is like, this is a super common pattern, I think, where you'll see, maybe you'll get an alert because you see that, consumer lag is spiking on a Kafka topic or Kafka broker, or perhaps you are getting alerts from your databases. Something's wrong. Resource utilization is high, queries are timing out, or whatever. And if you just have metrics, quite often it's really challenging to get to the end of the chain there, because metrics have pretty high cardinality limits usually, right? So you can't necessarily have every single value represented in a metric. So maybe a few things. Maybe query time by service. If you have a couple hundred services, okay, so that gets you a little closer. But then you're stuck because you can't do something like, well, show me query time by service broken down by customer ID, or broken down by individual database requests, right? With the kind of correlated data that you get out of OpenTelemetry, though, you're able to really easily pivot from, I see that I have like high utilization or, query timeouts over here. Let me look at some exemplars for that, right? Let me look at some specific requests that were part of that bucket of like really high things. And maybe that actually lets me find that it's not even just one service. It's maybe one pod on one deployment, and it's one customer that is specifically having a really bad time versus, something else. And that gives me both more data from like a firefighting perspective, because it means that I know what the blast radius and the impact is of an incident, but it also helps me get better inputs back into my, like, how I'm developing software. Because if I keep seeing it's this one customer that keeps blowing up the API or keeps blowing up the DB, maybe the solution isn't isn't re-architect the software. Maybe it's like have their account manager go and be like, hey, what's up? You keep doing stuff that's causing us problems. Let's figure out what's going on. I think that's one of the benefits of having really good observability. It makes these problems more tractable because it's giving you the insights you need to really understand the problem and why it's happening, and not just that there's a problem happening.
And then one thing we talked about in terms of the collector, we went over some of the considerations, some things to think about when you're architecting your observability system. And one thing we talked about is this observability balance. Will you go over that?
I think one thing that is really challenging in observability is that you've heard the aphorism, fast, cheap, good, pick two. I think observability is almost a little worse in that case, because everything you're doing in observability is really trading off between like your data availability, your data integrity, and like the speed of access to it. Consider that maybe the best way to figure out what's going on in your system is to save 100% of the data it emits. And that's certainly possible, especially on a smaller system. But on a very, very large system, if you're like planet scale, then you're not going to be able to do that. It would require more storage to keep everything, keep a record of every event that happened than it would to actually like run your application, which would be silly. So, okay, you're making trade-offs now. Maybe you want to keep a lot of data, but not 100% of data. Well, do you want to be able to access that data quickly? Or do you want to be able to access it slowly? Because if you want to access it quickly, then you need to mess with the integrity of it, right? You need to sample some stuff out, and you need to have math that says, like, okay, yes, this is 1% of all the data, and I'm going to miss some stuff, but I believe that what I have left is like statistically representative. But then maybe there's going to be like one thing that is like really important that gets missed. So you say like, oh, okay, well, let me trade integrity for availability and start like tiering out my storage and say important stuff goes to the fast storage, less important stuff goes to the slow storage. But now that's trading off query speed again, because of what if I have to go and get into the slow storage to look for something. So you think about it as like a little puck, right? Like it's moving between these things. And there's no, like, I would love to say there's like one best answer for everyone's use case, but there's really not. What you have to do is you just have to keep in mind that these trade-offs exist, and this is kind of the axes that you're going to be trading around.
And that's really just smart in life, not to think you can get everything you want all the time, but to be like, okay, this is what's important to me, and this is what I'm going to prioritize. And having a mental model for that, that's observability specific, I think is invaluable. Is there anything else you want to say about the OTel collector, or any considerations before we move on?
Similarly to like thinking about the trade-offs in your overall observability journey, like how you deploy the collector matters too, right? Like there's ways that you can do tiering for that.
When you say tiering, what do you mean? I don't think we talked about tiering.
Yeah. So for example, you can say, maybe you put all your data into one collector. Maybe you say like, instead of that, we're going to have a collector for each type of data I'm getting, and then another collector that sort of consolidates all of that and sends it off somewhere. I think one thing that we said on the last thing was there's not one right answer, but there are good places to start. Look at how other people are starting. Don't necessarily copy what they're doing, but look at the website, look at the docs, discuss this stuff with people, and figure out like where are you going to start and where are you going to go. It is important to remember, like, everyone's needs are slightly different. There's not a silver bullet. There's not a like do it this way and it works for you every time. Observability is like any other part of software development and running a software system. Like, it's a muscle. It's a practice. It's not just a box you throw stuff into. It's something you have to do. You actively
iterate
do it
and evolve. Yeah. So what's coming next for the OpenTelemetry project?
So depending on when you see this, some of this stuff might be done or more done by then. But the two big things we're trying to get in now is, if you've heard about eBPF or continuous profiling, we want to make that also sort of a primary signal, right? A primary part of OTel. And continuous profiling gives you that nice like line of code level insights into what's happening in your software. And then we want to really kind of lean into this idea of events and having structured events as another important thing. Some of the names for that stuff might change, but we're not just stopping at metrics and traces and so on and so forth. We really do believe that observability data isn't about like these three pillars, like we said before. It's about getting a lot of like super contextual, highly correlated data and blending it together in a braid that you can use however you want. We don't optimize for a specific database or a specific visualization tool or anything. We give you the data and then we say, go for it. So the better the quality of the data, then the better, the more the ecosystem can kind of pick up and run with, what we've built. And that's, I think, the real goal.
So you can learn more at opentelemetry.io. But if someone has questions and wants to talk to a human in the community, what's the best way to do that?
So check out the CNCF Slack. We have an OpenTelemetry channel. We also have a whole lot of specific channels. So OTel-Java, OTel-Collector. If you want to talk to someone on GitHub, go start a discussion or open a issue for whatever language you're using. Be sure to kind of check us out in the, at CNCF events. So we're at the KubeCons, where there's usually a community day every year that you can keep an eye out for. And we really love to meet people in person and hear what you're doing with OpenTelemetry and observability more generally.
This was so fun, Austin. Thank you so much for sharing your time and your expertise with us.
Thanks for having me. This was great.
Ready.